In this tutorial, we are going to be looking at how to extract water body from a Landsat image. That is a satellite image in ArcGIS. You know, when you want to extract water body from satellite image, there are certain analysis that requires some kind of calculations, like combining bands and all that. Each of the Landsat image bands do have uh, their own advantage, what each of them work for. You know, we have Landsat 8, that is OLI, operational land imager. We have Landsat 7, that is enhanced thematic mapper. We have Landsat TM, that is thematic mapper. So there are certain things some of these things work for. There are certain things some of these things work for, which we are going to look at here. So in this tutorial, we are going to be looking at how you can extract a water body from a satellite image, because there are times when you are working on flooding, you may be required to extract a water body so as to make your work much more easier. So this is what we are going to do. And also we are going to look at image classification. You can classify image. You know, we want to identify image features. You know, each of these features on the satellite image, they represent a particular feature. You see vegetation, water body, bare land, that is normal ground land, and settlement area. So we are going to be looking at this, and also we are going to be looking at NDVI. So we are going to be using a satellite image for the NDVI. So that is normalized difference vegetation index. So the first thing we are going to be looking at is the normalized difference water index. So looking at it, the first thing is to bring in your satellite image. So we are going to be using a satellite image of 2006, 2002. So we are only interested in we are only interested in just 2 bands, but in this case we are going to bring 3 bands in case we want to do the image classification and the NDVI. So let's bring in 3. Let's bring in just about 3 to 4 bands. So let's just bring in 3 bands: band 2, band 3, band 4. So band 1 is the blue, band 2 is the green, band 3 is the red, band 4 is the near infrared, band 5 is the thermal infrared. But in Landsat OLI, which is the Landsat 8, the band 1 is not blue like the other satellite images. The band 2, the blue band starts from 2, 3 is green, 4 is red, 5 is thermal infrared, like that. So they have different configurations, they have different things. So here we are going to be bringing in band 2, 3 and 4. So we are going to be bringing out band 2, 3 and 4. So let's bring in the 4th band. So that is that. So the next thing you are going to do is you have to select a small portion area that you want to work on. You know, we want to extract water body now, so let's just focus on this small portion, or rather let's focus on this small portion. So let's say we want to extract water body of this in this area. So let's just focus on this particular portion. So what you are going to do in this case is we are going to clip out this area. So that will be the raster clip. because we have vector clipping for clipping vector data, and we have raster clipping for clipping raster data. So in this case, what we are going to do is that we are going to bring in the shapefile of Nigeria and see which area will cover this particular satellite image where we have this water stuff that we want to, that I want to extract out. So let's add the shapefile of Nigeria. So this is the shapefile of Nigeria. You can see this is part of Lagos. So this is part of Lagos. So let's add the one that contains the local government also. So this is there. So what we are going to do in this case is that we are going to cut out some part of Lagos State that has this particular water body, or rather we can decide to select just Lagos and right click on it here and export. Here you save where you want to save, so we can just say water. So that is it. So we don't need this again. So this is what we need now. You can see we only need this area. Now after we've done that, the next thing we are going to do is to clip out this particular area only. So for you to clip, just go to your Arc toolbox, go to data management tools, then go to raster, then go to clip. So here we are going to clip each of the bands. Let's start from band 2. So we are going to select this, then use input feature for geometry. So but here we only need two things. In this case, we only need two things, two images. We only need the green and the near infrared band. Now the 2 is the green band, the 2 is the green band, the 3 is the red. Then the 4, band 4 now is the near infrared. Now this is the near infrared band, that is band 4. This is the green band. Then this is the red band. So what we need here is only the green and the near infrared band, that is band 2 and band 4. So let's go to clip. Then let's select 2, that which is the green band. Then here, save it in a folder. Or let's say green. So that is green. So you allow it to run. So let's try it again. 22. Then we select water. So let us use don't let us select the input feature now. Let's just leave the clipping extent like this, and let's see how it will go. leave it to run. It will take time a little. Okay, it's done. So let's, this is the area extent we need. So we've done band 2. So remain just the 4th band. You see, we've done this one. It remains just the fourth band. So we do the same thing for that. So the 4th band. So in this case, we are going to select this output extent now, green. So the output extent of the other one, that's what we are going to select. Then NIR, so that is it. So we don't need this. So these are the 2 we need now. These are the 2 images we need. Now let's extract water body from this satellite image. So the next thing you do is that you go to your toolbox. You go to your toolbox. You go to spatial analysis 2. You go to math algebra. Then you select raster calculator. So looking at the formula here, you will see. You can see. So that is the green minus near infrared, then the green plus near infrared. So follow that procedure. Bracket green minus near infrared, bracket close, then divided by bracket open, green plus near infrared, bracket close. Just say NDWI and run. NDWI should not come like this. Let's see. Green. 2 is green, 3 is red, 4 is near red. So green. So let's make use of the latter image. Let's see. Let's make use of this. Let's make use of this. So 2. Let's say 2 and 2. Okay, 4 and 2. That is what we need. 1 is blue, 2 is green, 3 is red, 4 is near infrared. So we only need this area. Or rather, let's go to another area. Let's find another suitable area like this. Let's find another suitable area like this. So let's just bring in the map of Oyo State. So this is it. to these certain rivers within the state. So let's try to select so you cut the map of Ibadan. So this is the map of Ibadan that I already created. So let's remove this. So I don't need this. So this is it. You can see these are the areas. You can see the water bodies that I decided that I want to cut. This is it. So you can use it this way. Then another thing you can do that I want you to know is it can be another process, but you can do it. Suppose you want to cut the water bodies here, just go to catalog, go to your folder connection, select any folder, right click on it, go to new, then go to shapefile. You can just say boundary. That is square street. Then here select polygon. Here select a coordinate system. So select the coordinate system, then click OK. Now after you've created the boundary, now go to your editor tool, go to start editing and select your boundary here, then go to start editing. That is another thing you can do, which is quite also easy. Let's say you don't want to use the extent of the map. So here, once you've done that, just you will see something like, you will see a create feature here. Just click on it, then click on it here. Then you can digitize it here. Right click on this, then go to you can just go to direction. You can see, just type 360. You can see how straight the line is. Then click here, then go down again, then right click, then go to direction. You can see, just type 260. Or rather, press direction and type 270. You can see. Then again, just click, then go to this place, just put your cursor here, then right click again, then go to direction and type 180 degrees. You can see, but don't let me do that. Let me just do 172. So this is what I need. Just click. You can see, once you want to finish, just double click on it to finish it. Then here, change your boundary to give it like true boldness. Then here, save edit and stop editing. You can see. Now after you've done that, now go to your app toolbox, go to your data management tool, and go to raster, then go to raster processing, then click. So here, select the raster to cut, then select the boundary you want it to look like. Then here, just type green. Let me just say green one. You can see. Then another one, just go to the app toolbox again, press click, click, Then here select the second one, which is the near infrared boundary. So NIR NIR NIR1. So use secret future, then click OK. You can see if you uncheck this, you can see this is what we need. So when you unselect the value, you can see. So that is the extent of what we need. Now the next thing is go to your toolbox. Go to your spatial analysis tool, then go to math algebra and press calculator. So here, bracket open, green, minus near infrared, bracket close, divided by bracket open, green, plus near infrared, bracket close. Then here, just type NDWI or something. Just click OK and let's see how it will run. Okay, this is okay. This is good. So once it's like this, you can see that the water body is already coming out. So if you click on this and change, if you click on this and change this to Olo, you will see. You can see if you uncheck this, you can see that we're only having this, but it is still in raster format, so we need to convert it to a vector format. So the next thing is that you go to your toolbox, you go to your conversion tools. So that will be from raster to polygon. So here, select the NDW. So you can just say water body, then save, then click OK. You can see it's already converted. So the next thing you are going to do, you can see that it's still in kind of polygon, and it's still in kind of the size boundary, the size of the boundary. So the next thing you do is you press your shift key, you click on this, select feature, then you press the shift key, then you select all the rivers. So you select all the river inside. So select anyone you could select. You can see. Select anyone you could select. Then right click on it. Then go to data and export. So see. Let us see. You can just say let's say reef. Click OK. You can see if you remove this, you can see now that we are able to extract the water body. So you can give it any color you like. So let's give it a blue color. You see, this is the shapefile of the water body. So if you bring in the satellite image, you can see this is the shapefile of this is the shapefile of the water body on the satellite image that has been extracted out. Now, the second thing we need to do is image classification in ArcGIS. So for you to start a new window, just click on this, go to blank mountain, click on it. So the first thing is to add your satellite image. So in this case, I'm going to use the 2019 whole eye image. So and there is what we call color composite, and the band combination for color composite for whole eye operational land imager is band 3, 4, and 5. But the first color composite combination for Landsat ATM and CM is band 2, 3, and 4. So the first color composite will help you to be able to identify features easily. So let's bring in the band 3, 4, and 5. So let's bring in the band 3, 4, and 5, and let's use the area extent of Ibadan. You can see. So I'll bring in the shapefile of Ibadan, but to do that, you can just cut it out from the normal satellite image and just cut it out. So from the normal shapefile rather. So this is Nigeria as a whole. This is Nigeria, you can see. This is Oyo State, this is Ibadan. Then you bring in the one for that contains local government as well. So these are the part of Ibadan. This. So now if I want to cut out Ibadan, just select your select features, then press your shift key and start selecting one by one. So right click on this, go to data, then export. Say Ibadan, just the IPD. You can see Ibadan has been cut out. So you can now uncheck this, you can remove this, you can remove this. So this is what we need. So click on this box, then go to this place, then give it a boldness. So the next thing now is to click each of these bands to this normal shapefile. We click each of these bands to this normal shapefile. So the next thing you do is click each of these bands, make it have the same shape as Oyo State. Now the next thing you do in this case is you go to your toolbox the same way we cut out the last one, data management, tools, raster, then clip. Then here, select the first band, which is band 3. That is the green band. So just say band 3. Then the second one as well, band 4. Start band 4. Band 4. Band 4. band 4. Then the last one, let's select band 5. Band 5. So uncheck all this and let it remain just this. You can see. Now the next thing is to create your color composite. So click on Add to box. Under that same tool, click on color bands, composite bands. Then here select band 5, band 4, and band 3. Then just say false color, no space. Let's go to this. Five, 4, and 3. False. And let's see. Give it to run. You can see the first color composite has been created. Now each of these colors have their own future. They have their own future. So this cyan color is the settlement area, that is the built up area. The red portion is the vegetation. The dark green portion is the normal bare land. Then this is the water bodies. So let's start. The next thing is to pick our training sites. Then we'll pick our samples. So to do that, just go to training sample manager, open it here, drag it somewhere here, then click on draw polygon. So let's start with built up. Just click on it. Then once you are through, just double click. It will appear here. Then pick another sample again. You can pick as many samples as you want. Double click. Once you are through, just double click them. So now, after you've selected what you want to select, the next thing is to just press your shift key and select each of these classes that you have selected. After doing that, just click on this and match. Then double click on this and edit and type built up. Then the next thing, let's go to vegetation. Pick training samples for vegetation. So you pick training samples for vegetation as well. So you pick training sample for vegetation. So after you've done that, click on this. Just press your shift key and select everything you've selected. Click on this to match them. Just type vegetation. The next thing, let's pick beer lance. So you should be careful when picking it. So after you've done that, press your shift key to select all this, then merge as well, then click on this and type beer lance. Then water body, so if you make a mistake, just press your escape key. So this is it. Then click on everything to match, press your shift key, and match. So call this water body. Then after you've done that, you create a signature file. This is it. Then you create a signature file because that's what we are going to use. Let's create it inside here. This is signature sig sig.gsg. Then after that, you can save it. So just close it. Then now the next thing is to classify. Go to your classification. So click this to go to normal extent menu, to extent, to normal extent. So go to classification. You can see we have maximum likelihood, we have principal component, we have isocluster and others. So let's use maximum likelihood. So here, remove this and bring in just the first column. That's the only thing we need. Then here, this is the signature. This is where you are going to input the signature file you created. So just locate the signature file folder. Okay, this is it, the signature file. Then open. So here, just see class. Then click OK. So try to go to it again and try it again. So yeah, you only need the first color. Bring in the signature file. The signature file. So in this case, save it as just, let's say, max, and let's see. Okay, that should run. Okay, let's try it again. So here, let's use the band 5, 4, and 3. Let's see. So let's run. One thing I want you to know is, you know, the first time when we tried to classify, it was bringing out error, it wasn't classifying. That was because there is an error with the software. So for you to correct that, when you are performing an analysis and you notice that such thing is happening, or currently, the best thing is close the software and open it back. You close the software and then reopen it. Then once you reopen it, you are going to pick your training site again and all save it and save the signature file. Then after you've done that again, over again, you now go to classification and go to maximum likelihood and retry it if it will go. You can see this is fast. So then input your, this is another signature file. You can see this is another signature file that I created again after reopening the software. Then go to open. Then here, let me see. Let me write max. That is maximum likelihood. Then run. So run it again. It will run. You can see now this one now is the built up. These two is the bare land. These three are these two. This one is the vegetation. This is the bare land, and this is the water body. So here, let's change the color of the view top to another color. Let's try to change the color to something. So let's use this. Let's try to see this. This is too colorful. Try to use something like this. Okay, this is okay. Then vegetation, let's try to use this. Then bare land, let's use orange. You can see. Then water body, let's use blue. So that is the water body. So let's clear the training samples. You can see this is the land use land cover map. This is the land use land cover map of the area. You can see these are the water body. So let's try to use another color, something deep blue for the water body. Yeah, this is okay. So this is the land use land cover map of the area. So if you, in case you want to lay out this, just click on this layout view here. You can see, just click on this to drag the map inside. So increase the size of the map. So this is where you will insert all your features, the legend, everything that pertains with the map. So here you give it a border. So this is the legend. You can see. So another thing I want you to know is, if you don't want it to be in portrait view, you can change it to an horizontal view. Just go to layout. Okay, you can see this is this landscape. Just go to landscape and go to finish. You can see it will definitely change to a landscape. So that is just about how to do the layout. So once you add your legend, this is where you add your north arrow to everything. So this is where you add your north arrow, whichever north arrow you want to use. You can see the north arrow are many. So here you insert the scale bar, go to properties here, then here select kilometers, then here just limit it to km, then apply OK. So this is it. You can increase it. Then here also you can insert the legend. So you can give it a this, then next finish. So this is the legend. And see, this is the legend. Now if you want to create the grids, your latitude, your coordinates, just right click on it, just right click on this, go to properties, go to new grids, go to next, here select labels only, and here next finish. Then here you go to your properties to edit it. So let's select area, but then increase the size, that is the font. So let's select something like 28. So here, okay, let's click OK, then OK, apply. You can see that the intervals are just going, they are straight like this. So right click on it again, then go to properties. So go to labels, then go to left and right. So interval also, you can reduce the interval. Let's use 18 here. Yeah, okay, let's use 16. And okay, so let's try to increase the font again. Okay, this is it. You can see this is your map. Then if you want to export it, just export your map. Just go to file, export map. So you can select anywhere, map, then export. So you can go to your desktop and view it. You can see this is your layout map. This is your map. So the next thing we are going to look at is NDVI, that is normalized different vegetation index. Normalized different vegetation index. So let's remove this. Let's remove this. Let's remove this. So well, let's start a new view. So let's bring in our maps. Looking at it here, you will see NDVI. This is NDVI. Okay, this is NDVI method. You can see near infrared minus red, near infrared plus red. So your band 3, That is for Landsat. TM and ETM is red. Your band 4 is near infrared. So in this case, we are going to try the Landsat O-line. Bring in the Landsat O-line. That is, let's bring in the band 3, band 2. So band 3 is the green, band 2 is blue, band 3 is green, band 4 is red. So we need red. Then 5 is near infrared. So that is it. So what we are going to do in this case is we can use this whole image just to find out the NDVI. So NDVI is a method that is being used in identifying the state of a vegetation, whether the vegetation is okay, whether it's partially okay, or whether they are dead. So they majorly use it on crops, like to know the crops that are healthy, to know the ones that are not healthy, to know the ones that are partially healthy. That is what they use it for, just to know the state of the vegetation. So it ranges between -1 to +1. So here, let's use the image here and look at what it will give us. So let's just go to let's just go to your image analysis. This is it. Window. This is image analysis. You can do it there. Then you can also use calculation. Going to this. Let's use calculation, which is far better. So let's use the spatial analysis too. Math algebra. So this is band 4. It stays near infrared minus red. That is band 5 minus band 4, bracket close. So near infrared plus red. So divided by divided by bracket open, band 5 plus band 4, bracket close. So this is it. Then let's run. See what it will give us. If it is a Google Earth image, if we are using a Landsat image, we use the best method to use is the calculator. But when we are making use of a Google Earth image, that's when we use this image analysis window. So let's see this. So let's make use of this. That's like the image is fault. So this is green. This is red. This is near infrared. So let's use the calculator again. This is bracket open, this minus this, bracket close, divided by bracket open, this plus this. bracket close, save, then run. And let's see how the results will look like. You can see this is a better result. You can see this is a better result. These ones that was identified, you can see that this is a built up area, this is the water body, and this is the beer land. What this shows is that it's going to classify water body as a dead vegetation. You can see water body, beer lands, and settlement area were classified as dead vegetation. These now are the vegetations that are healthy. These are the normal vegetation. So it's classified other features apart from vegetation as dead vegetation. And these areas now, we have some vegetations there, but most of it are bare land. So it's classified bare land as a dead vegetation, and it's classified all this vegetation as an healthy vegetation. So that is one thing about NDVI. It will classify other features, water body and other. It will classify everything as dead vegetation except the vegetation itself. So that is one thing about NDVI. So but NDVI is most suitable for high resolution image, which is the Google Earth image. So especially someone who is in the aspect of agriculture, you want to know where the vegetation that are healthy, the crops that are healthy, the ones that are partially healthy, the ones that are not healthy, the ones that are dead. You want to know, then you can actually use NDVI to identify them. So that is all about NDVI image classification, and also water body extraction from the satellite image.